Okay, and we should be live. Let me just wait to see that it's actually working. All right. All good? Yeah. Okay, good. We're all good. Right, let's get into it then. Okay, so oh, no, still got feedback. So last time we left off at we did error handling. We did things like being able to halt your program, terminate your program, making sure if the function can be the one to find the error, if not the caller, and if not the main will eventually. So now we're on to input, i.e. preventing the user to be able to actually input programs or rather entries that we don't want them to, or if they're supposed to enter only a number, then we need to prevent them to only doing a number. So, and we left off at these three. Uh, so it can be pre or it can be post. And you got sorry, as the user types, prevent them. Let the user type whatever they want, post, and then another post to handle error cases. Okay. So we generally separate input text errors into four types. Input extraction succeeds but is meaningless. Input extraction succeeds but the user enters additional input. Input extraction fails and input extraction succeeds but the user overflows the numeric value, such as if you had done an unassigned integer and they had entered a negative. So now we need to go through. So just do error 1, error 2, error 3, error 4. Cool. So now we're going to go through each one of these and so error 1. Extraction succeeds but input is meaningless. So this is the simplest case. Consider the following extraction. So I'm just going to copy that as an example. Enter a decimal 5, and they enter K. In this case, the user asks, we ask the user to, the solution here is to do input validation, which was validating input. Check whether the user inputs is what we're expecting. If not, return the value to the caller. If not, tell the user something went wrong again. Okay, so um, so we would need to do this. So in our get operator, so we would wrap all of this essentially in a no, sorry, in our get operator, we would wrap we would put in a below where the user enters. So here we want to check whether the user entered a meaningful input. So while no, hang on a minute. The whole thing needs to be in a while loop. So while true, which will then create an infinite loop. So while true, I'm just going to indent that a bit. Check whether the user entered a meaningful input. Then we got to switch our op, i.e. this here, and then we can do case plus case minus case times and then we return op. So we return it to the caller. Otherwise, we want to say, oops, this is a invalid input. Oops. So let's just give that a go. So we'll enter a number, we'll do 3, we'll do Q, and we'll do 3 again. But that means surely we need to adjust this, don't we? Because we still get this. Um, Unless we need to do that. Um, so why that works but mine doesn't? So what is the difference between that and mine? Got while true. Ah, that's why, because we're returning op here. Okay, I understand. Previously we had return op here, but we want it here instead. So now if we run it, uh, 2p, and then we're just stuck in an infinite loop until until the user decides to enter the correct values. And then if we did times and then 2.2, and there we go. Okay, cool. So it's just the return shouldn't have been there in the place that it was. Okay, I'm fine with that now. Uh, so extraction succeeds, but with extraneous input. Mm, yeah. There's 7 in the buffer, I guess. So it's easy to ignore characters. So to ignore all characters up to the new line, we can pass numeric limits, STD standard stream size max to ignore. This returns the largest value that can be stored. So we would wrap it all in a function, and then once we've wrapped it in a function, so standard character in ignore, and then we do standard numeric limits, standard stream size max new line. So we would do in our get double, So when the user enters a standard character input, we want to ignore standard numeric limits with the type standard stream size, and then with another scope resolution operator of max, and then we want to ignore new line. Then within our get double, before the return, we want to ignore, so that should be ignore lines, not ignore limits. Okay. So now 5 times 7, 5 times 7 again, and it just goes 5 times 5. Error 3, extraction fails. Okay. When a user enters a character A, that character is placed in a buffer. Then the exertion operator tries to extract A to variable X. Which is a type of double, so this one here. Since A cannot be converted to a double, it cannot do the extraction. Two things happen. A is left in the buffer, and standard character input goes into failure mode. Once in failure mode, future requests for the input will silently fail. Thus, the calculator program output prompts still print, but any request for further extraction will be ignored. This means that instead of waiting for us to enter an operation, so does that mean that oh no. In order to deduct the prior extraction has deduct that the prior detect sorry that the prior extraction. Yes, because standard character output typically stores things in a buffer. Um, so we need to clear things in the standard character output. Using the clear function. So in our get double, just above this, we need to take care of it accordingly. So if standard character input, if not, oh, sorry, there we go. So just click the wrong thing on my OBS. Should be all back now. Yeah. Okay, cool. We're still good. No, not that. Let me just check. Yeah. Okay. If not standard character input, handle the failure. So standard character input dot clear this puts us back to normal mode, and then we ignore the line from this to remove the bad input, and then we continue, which essentially skips here. But we're getting an error on our continue. Why is that? may only be used within a loop. So then we need to wrap all of this in a while loop. So once we've ignored that, we can then continue, i.e. we skip over this and we go on to here and return x. For fundamental types, a failed extraction due to invalid will cause a variable. So this is a simpler way to do it without using an if statement. So we've done Boolean success with the initializer of Sarah Gilbert. Then we do standard then we ignore the line. And if success, okay. I still want to do that. Checking for EOF, end of file. There's another case where we now consider Okay, so that's that. So what happens if we do Control D in our program? So we do 5, and then we do Control D. Ah, okay. So it is important. It just gives us a infinite loop. Interesting. So what if you just did Control D normally? Ah, oh, I just closed it. That was it. What about if you did Control D here? Ah, interesting. So, um, that is very interesting. Um, so, I've never come across a um, end of file before. Clear, failed. Then in our body, we want to check for failed extraction if there is no standard character input. If the previous extraction failed, then if standard character input is end of file, i.e. if the user has entered an end of file, which is going to be that. So if that is the case, we exit the standard character input. Whilst in so standard character input, and we standard character input exit, and then we shut down the program. This is interesting. Shut down the program. Then we need to handle the failure. So standard character input, clear, then we ignore lines, and then we return true. Interesting. So will that actually work straight away? But we're not calling it anywhere. What have I got an error on? Because I need to do like that, right? Yeah. So if we do Control D, we still get the error though. So surely we need to call it somewhere. No, I think we call it in here. Not here. I know it's only one line, but I just want to. Would that work? No, still not. Okay, so it works there, but it doesn't work if you're doing the first one. Why doesn't it work for the first one? Because we need to call. That's why. Because we're calling it here, but we're not calling it when we're getting the double. So if prevent the infinite loop of end of file. So if standard character input end of file, we need to call the function, then we will be calling our clear failed extraction, right? Well, let's have a look. So we're asking for a decimal number, and I'm going to do Control D. Good. Okay, good. So that works. So we just needed to call it. So now what we need to do is error 4. But actually, first of all, what I want to do is so if I did end a file on this, no, that doesn't work. That is very interesting. If the ender file is not the first character input, yes, as we saw in our terminal. This is very interesting. I've never come across this before. We would then call clear failed extraction in our get double and get operator. Functions like this. And this. We wouldn't need to call it here. I've got rid of it anyway. Okay, so error 4. I think I'm going to take a quick break here and I'll be back in a minute. Okay, and we're back. Okay, sound all good? Yeah. Alright. So that was very interesting about the end of file. I never come across it before. So um, so error 4. Extraction succeeds, but the user overflows a numeric value. As we've learned with previous lessons, the numeric value of different size integers, signed um, short, integer, long, long, and they could either of that could be signed or unsigned with different values or ranges. That's what that's what I believe he's talking about there. So consider the following example. We're using the C standard integer, and we're using integer 16 bits. And remember, standard integer 8t is also basically a character. So enter a number between, and the user enters 4000. Enter another number. Yeah, so the user entered 4000 too large, and as a result, it overflew. When entered, um, when the entered value is larger than the closest in the range, consequently, x is left with the assigned value of that. Yes. Any additional? Okay. So let's put it all together. So we're going to do include oh no, we'll leave it for now. Cool. Sorry about that, is annoying. So anyway, right. As you write the program, as you write programs, consider how users may misuse it, such as the end of file. Okay, yeah. So let's save that. Now let's do conclusion. Okay, so I believe the next one is the last one before the quiz. Yeah, it is. So assert and static assert. Okay. So the only static we come across is static variables and static functions and static cast. So only a few. In a function, any function that takes parameters that call them. For example, the following code. So we got a void print division, get rid of int, and then we're passing in int x, int y. Then within this body block, we're going to be doing if y does not equal 0, then we will be doing standard character output, and we will be using static cast, and we will be converting, we will want to creating a new type of double, and we will want to do, sorry, that should be in crocodile, and then we'd want to be converting x divided by y. Else we want to be standard, we're producing a character error of error could not divide by 0. This function does an explicit check to see if y is equal to 0, since dividing will be, yeah. Yeah. Both of these options are problematic though. If the program skips statements due to an error, this is essentially failing silently, especially while we are writing and debugging programs. Silent failures are bad because they obscure the real problems. Even if we print an error message, that error message may be lost among other program output. True. and it may not be obvious. Some functions can be called and it'd be hard to know what the error is. If the program terminates via, then we lose our stack. Okay. Standard abort is a better option as typically. So standard exit. So if we then we will lose therefore standard abort is a better option as okay. So preconditions, invariants, and postconditions. In program, a precondition is a condition that must be true prior to the execution of some section of code. In the prior example, so y is not equal to 0 is a precondition. Is a precondition that ensures y has non-zero value before dividing y. Preconditions for functions are best placed at the top using early return statement to call back to the call if the precondition isn't met. So we got avoid print division with integer x and integer y coming in. There you go. So if y is equal to 0, then we do a standard character error of error could not divide by 0. And then we do that. And then we also return so we know that if we get to this stage, then y must be not equal to 0 because of this. And then we can convert it with static cast, convert it to a double. No, again, that should be in, and we want to convert x divided by y. Okay, that makes sense. And so that was a precondition. That was a precondition. An invariant. So we got precondition, an invariant, and postconditions. An invariant is a condition that must be true while some section of code is being run or being executed. This is often used in loops where the loop body will only execute if the invariant is true. So the invariant is a condition that must be true. Yeah. A post condition is something that must be true after the execution of some section of code. So assertions. So we're doing static assert and assertions. Using conditional statement to detect invalid parameter to along with printing error message and so an assertion is an expression that will be true unless there is a bug in the program. Okay. If the expression I just want to get used to saying it, if the assertion expression evaluates to true, the assertion, so it's assertion statement, not expression. Although if the expression is true or false, the assertion statement does nothing. If the conditional expression evaluates to false, an error message will be displayed. And the program will be terminated via the error message typically contains the expression this error message typically contains the expression that failed as text along with the name of the file and the line of the code. Yes. So in C++, runtime error assertions are implemented via assert processor macro. So, in C++, runtime, because remember we have runtime, but before that we have compile time. Before that we have compile time. So runtime assertions are implemented via the assert preprocessor macro, which lives in the cassert header. So, for example, did I copy this by the way? Just check. No, I just want to copy it though. Just so I have it as a reference. Okay. So now we can get rid of that. We can use include C assert. We can do the typical include input output stream. And then we're going to be using standard square root. So we need CMath. So for assert, for standard square root. So we're going to have a double of calculate time until object hits ground, and then we're going to have a double of initial height, sort of like we had when we were doing the ball calculation, and then we're going to have a double of gravity, and then within the body block we'll assert gravity to be greater than 0.0. The object won't reach the ground unless there is positive gravity. This means the object will not is positive gravity. And if initial height is less than or equal to 0.0, then we want to return i.e. This means the object is already on the ground. Then we want to return standard square root of 2 times initial height divided by gravity, which I assume is the fall rate. Okay. Then in our main function with a return integer, we want to call calculate object. So took and then calculate, and then we're going to be doing a double of initial height of 100, and we're going to do a gravity of minus 9.8 uh, seconds. Second with a line break, and then we're going to, as always, return 0 for our main function. When the program calls this, and it will be false. So let's have a look. So I call it, and as you can see, we got there. We've aborted. And as you can see there, we got, as I said, the error message will contain the text expression that failed, i.e. the expression. It will contain the function, and it will contain the file name and the line. So what you could do is you could go there and you would see here. So the following error. So this would produce this error. Yeah, although okay, so asserts are useful. Although making assert more descriptive. Sometimes okay, I'm going to take a quick break here and I'll be back in a minute. All right, let's continue then. Okay, so where were we? Yeah. What does it even mean? Clearly found was false, since it triggered it. So assert gravity equals 0. So for example here, I assume you could just do this. First of all, let me do that. So assert so in our previous example, we could do something like this. Gravity cannot be less than 0 since we are here on Earth, right? And then we run it, we clear this, and there we go. We got there. This is where it failed at. Gravity cannot be less than 0 since we are here on Earth. And we still have the function, which we can go to, and the file name. Cool. So, let's see how using assertions for unimplemented feature. Assertions are sometimes used. Okay. Yeah, that makes sense. Ndebug. Ndebug. Yeah. The assert macro comes with a small performance cost. Mm-hmm. So the ndebug so the macro of ndebug essentially kills the assert function and must be included before any includes. Okay. Such as this. Such as this. Okay. Static cast. Static assert, rather. Static assert. Static assert. Static assert. So checked at compile time rather than runtime with static assert, therefore causing a compile error. That makes sense. So unlike assert, which is declared via the cassert header, the static assert is a keyword and is a keyword like static cast and therefore does not need a header. Okay. Does not need a header. With the following syntax. So following syntax. So static assert condition diagnostic message. Then if the condition is not true, printed. Okay. Such as the following example. Let's have a go at that. So you got static assert So you got static assert, and then we got the condition of size of long integer. Then it must be equal to 8. I didn't include a semicolon, a comment, no I did. So long must be 8 bytes. But it's not, though, is it? It goes, it's 32 bits, which means it's 4 bytes? Or am I tripping there? Oh no, it depends on your, yeah, it depends on that. So static assert size of int less than equal to 4. Int must be at least 4 bytes. And then in our return function, we'll simply return 0. No, the frame is so we good on that. We just need the stream to catch up. We're good on my, no. Maybe if we just wait. We good now? Uh, that's a bit delayed. I'm just gonna wait for it to let me just check the volume. Okay, so I think we're all fine. Um, just not stream wasn't strong enough and quality was poor. But I think we're all good now. Okay, so let's run that again. Let me just clear. Maybe because it was yeah. So what if we did must be equal to 4? Would that be better? Would that produce the error that we want? Yeah, there we go. So there we go. We made we made long equal to 8. Sorry, to 4. So if your device takes long as 8 bytes, you might need to change that just a bit there. Change that to 8. And then we'll run it again and we shouldn't get any errors. Okay. That's probably why, because we were running at compiled. Okay. So last one. Um, so prefer static assert over assert when possible. Assertions and error handlings are similar enough that their purposes can be confused. So assertions are used to detect programming errors uh, by documenting assumptions that should never have happened, and if they happened, they're the fault of the programmer. Assertions do not allow for recovery after errors. After all, if something should never happen, there is no need to recover from it. Because assertions are typically compiled out in release builds, you can put a lot of them in without worrying about performance. Error handling is used when we need to gracefully handle errors that could happen in a release build. So I assume there in those cases you would use static assert. So If x is 0 and y is 0, should we use assert or error handling? The best answer may be both. During debugging, if the function is called, so assert seems appropriate. However, this could reasonably happen. Okay, yeah, that makes sense. So we suggest use assertions to detect programming errors, incorrect assumptions, or conditions that should never occur. Is the program's responsibility to fix these? Yes. Use error handling in issues we expect to occur during normal operation of the program. Use both where something, so the best practice is this. Set assertion limits and warnings. Use assertion limitations. So there are a few pitfalls. So there are a few pitfalls and limitations to asserts. First, the assert can be improperly written. True. If this happens, it will fail to report. Second, your assert expression should have no side effects, as the assert won't be. Yeah. Use abort function. Also note that the abort function. Okay. Okay, so chapter 9. Okay, yeah, so we're definitely able to finish. So chapter 9 summary. I was thinking it would be a long quiz, like the last one. So scope creep occurs when a project's capability grows beyond what it's intended. Software verification is the process of testing whether or not software works as expected. A unit test is a test designed to test a small portion of code, typically a function call in isolation to ensure a particular behavior occurs as expected. Unit test frameworks can help you organize your unit tests. Integration testing tests the integration of a bunch of units to ensure they work properly. Code coverage refers to how much the source code is executed while testing. Yes, so you got code coverage, statement coverage, and loop coverage. No, branch coverage. Statement coverage, branch coverage, and loop coverage. Statement coverage. Branch coverage refers to percentage of branches. Loop coverage refers, also known as the 0, 1, 2 test, means tests how many times you've iterated. Tests how many iterations work from 0, 1, and 2. The happy path is when no errors are encountered. The sad one is when a failure state occurs. Non-recoverable or fatal errors is an error to serve that the program to is an error that is so severe enough that the program can't continue running. A program that errors well is robust. A buffer is a piece of memory set aside. The process of checking whether the user input conforms to what the program is expecting is called an input validation. Standard character is an output stream. A precondition is a condition that must be true before the execution of code. An invariant is a condition that must be true while some component is executing. And a postcondition is a condition that must always be true after the execution of some code. The assertion is an expression that will be true unless there is a bug in the program. C++ runtimes are typically implemented using the assert preprocessor macro, and remember we can customize that using the AND operator. Assertions are typically turned off in non-debug code, or the macro preprocessor #ndebug. A static assert is an assertion that is evaluated at compile time. Assertions should be used to document cases that should logically be impossible. Error handling should be used to handle cases that are possible. Nice. So, we implemented high-low. Update out of bounds. Okay, so we need to go back to high-low game. Was it here? No, it was not. It was further up. So I'm going to copy and paste this. Into here. Then I'm going to because that should be lowercase for us. Yeah, for me. And now I'm going to Are we still alive? And I messed up a little bit. Yeah, we're still alive. Okay, good. Update your solution to out of bounds of e.g. 1 and 100. I believe I tried that last time and I still messed up. So what we're going to do is we're going to create an assertion. What would be the best way to do this? We do if we do So we want to use error handling. So if so play high-low, play again. I just have to get used to this guy's code. If guess is greater than number. So if guess is int. So then what about if we do here, if guess is greater than 100, we want to produce the standard character output of this, your guess is to no. The guess no. Your guess must be less than 100. So let's just see if that works. First of all, oh no, hang on, what did I do? Yeah, there. Okay, good. If guess is less than so what are we guessing from 1 to is less than 1, because we're guessing from 1 to 0, aren't we? From yeah, from 1 to 100. So that means we must therefore so if guess is less than 1, then we will do a standard character output of your guess must must be more than 0. I wonder if instead we can just do min and max rather than 100. Let's give that a go. So we do -1. Your guess must be less than 0. So if and then we want to break, right? Because then this will break the for loop. This will break the loop and go to the next iteration. Correct. Or am I tweaking? So -1. No, so we don't want that. We don't want break. We want to continue, surely. Continue to the next iteration. And we actually need this, don't we? Because we're doing in the body. So we run that. We then do -1. What am I doing, man? That should be there, and that should be there. And then we run it again. -1. Your guess should be less than 0. So now what I want to do actually is I want a line break. I want to clear this. So 101, your guess must be less than 100. And then -1, your guess must be more than 0. So we've got that, but he wants us to write in a separate function. So if we did I think it's fine there. And then so you don't want 43x, because if you enter 43x, you get a infinite loop. So how did we do that with the 5 times 7 one? Because I remember doing that explicitly. So let's have a go at that. So 5 times 7. What did we do? We used, I was thinking of end of file, but it's not that, is it? So where is actually end of file first? So it won't be that. It was before end of file. So where does end of file start? Okay, good. So end of file. Okay. So our 5 times 7. So this is where it was. So we want to use standard ignore. So we want to to make sure we don't get an infinite loop when the user enters something other than a number, we will use standard character input ignore, right? Because and then standard, so we need to so we will need to add the include limits header. So we'll do that now. And actually that should probably be above that. And then include limits. So we're gonna function. So void ignore lines, and then we're going to be doing return a body, and then we're going to be doing standard character input. Standard character input. No, standard character input ignore, and then we're going to do standard. This is where it loses me. Standard numeric limits. Numeric limits. Then the type we want to change it to std stream size, and then the expression we want to change. No, another scope operator of max. Then we want a line break. For our other argument. Standard character input, no. Like that? No. Like that? Yes. So, I also want to make sure that the end of file isn't possible, i.e. this. By pressing Control D, you get this. So I want to also avoid that. So end of file. I know, actually, let's sort this out first. So get double. So in our play game, we need to implement ignore line here. So here, no. We need to implement ignore lines. So I think if we put it here, will that do anything to it? So we'll do 43x. Okay, good. So that did do it. So we then place the ignore lines here, as this prevents the infinite loop. Cool, that makes sense. That makes sense to me. Infinite loop. But now, I know he doesn't say it, but I want to do what if the user enters 5 times 7? This is too low. What if he enters A? So A. But first what I want to do is I want to do prevent the user from being able to cause an infinite loop for by using end of file. So now we'll go back down to end of file. End of file. So we already have limits. Yeah. So we want to create a Boolean. So the function will be a Boolean. Then once the function is a Boolean, it returns true if extraction failed. So bool clear failed extraction, clear failed extraction. No parameters. Then check for failed extraction, i.e. if, I believe this is right, standard character input is the end of file, then what do we want to do here? We want to just exit. Okay. So if the user enters an EOF, then we simply exit with 0, was it? Yeah. We simply shut the program. Then we want to handle the error and return to normal. So using standard character input, and we're using clear to clear the standard character input buffer, right? And put it back in normal mode. Then we want to return false. No, return true. Because this should be in our we need a wider if not standard character input. Then all of this needs to be in our nested if statement. Get rid of that. Then we want to return true, because this means, so this will return true since the extraction would have failed. And then here, and then finally we return false, like that. Yeah, return false, i.e. the extraction has not failed. So then, writing it is all good, but now we need to implement it. Ignore line. So how did we do it previously? It's going to be around here, I think. So we would call it after this. So if not standard character input, end of, no. Sorry, if, so we're not checking not if, we're checking if standard character input is an end of file, then we need to call clear extraction. So then if we run the file, then if we press Control D, good, we've ended the file. We simply shut down the program. Yeah, we simply shut down the program. And I just want to add a quick line break to get rid of that semicolon, that percentage. Why does that not? maybe you're not allowed to do that. Okay. So what if we then typed in A? Would that also cause it? Yes, it would. So now we need to clear, which is error 1, i.e. if you enter K, so in our get operator, I so here's what it would look like. If standard detect the fan. So if standard so then in here, so that's checking for also I don't like this, the fact that I've got he does 4 spaces whereas I typically do 2. But anyway, enough about that. So this is checking for if the user enters control plus D, aka end of file. Now we're going to check for if not standard character input, and then we're going to be doing, yeah, if not standard character input, and then within this we will want to do standard character input clear to so if the previous extraction. This error handling is interesting because it really allows you to understand what you're doing in the code. We want to clear the existing buffer that is created and put us back to normal mode. Then we want to remove, let's get it right. Then we want to remove via ignore lines. We want to remove the bad input, and then we want continue, i.e. go to the next iteration. So then if we run that, and if we do A, good. Good, okay, very nice. I'm happy with that, and I'm happy where we are. So, yeah. So that is errors done. I'm happy with everything. Yeah, you could have done it there, perhaps. And he did the more simple version. He did a while loop as well. Yeah, I think what would probably be best is if we did max here and min here. Would that still work though in my code? So you do 101. Cool, it does. Okay, so next lesson we're going to be doing left off at at lesson 10.1 implicit type conversion, and obviously we've done some of that previously, so hopefully it shouldn't be too bad when you're learning it yourself. Okay, so you can see here we're going to be doing type conversion, then we're doing functions, then we're getting into pointers and references and enums and structs, the interesting stuff. Okay, so what we're going to do now is we're just going to log it. So day 20, and what did we do today? Today we did, let it load a bit. Okay, so today we did types of invalid text and the 4 errors and the 4 common errors. I'm just gonna okay, next we did error 1, error 2, we did also end of file infinite loops and how to deal with them. We did standard character input and needing to create a function for ignore lines to avoid another infinite loop. Yep. Error 4. Then we did assert and static assert. Then we did preconditions, invariants, and post conditions. Then we did some assertions. Then we made our own assertions with the and operator in assert. Via the include assert header. Sorry, then did n debug. Then we did some more on static assert. Then we did assert versus error handling. And then we did the quiz. Cool. Tutto bene. And today's date is the 18th of August. Okay, cool. So tomorrow we're going to be starting on next stream, whenever that is. We're going to be doing, let me just clear my terminal. And let me just clear those. Okay, cool. We're going to be doing types, conversions, type aliases, and type reduction. And as you can see in the last one we did previously. Okay, cool. So hopefully you enjoyed that, and if you're following along, hopefully you're enjoying C++ as much as I am. Yeah, so if you are, let me know what your thoughts are. Let me know what I did that I shouldn't have done, or let me know what I did well. Just help me improve. And yeah, I'll see you in the next one. If you want to leave a comment, leave a like as always, and subscribe. And I'll see you in the next one. Okay, bye.